Pneumatic proportional valves are electronic flow control valves. Engineers specify them whenever output flow needs to be variable or controlled. A variable current input to the valve's coil produces a corresponding flow output. Proportional valves have an inlet and an outlet port. They are manufactured to reach maximum flow at a maximum recommended current. From a regulated upstream pressure source, you can expect the valve to deliver repeatable performance for millions of cycles. Valves are selected by their flow capacity at a specified supply pressure. For best results, users pick a valve with a maximum flow capacity safely above their application's needs. Although proportional valves are rarely used in this manner, most manufacturers present their valve's capabilities in the form of a graph. Here, we're animating its full operating range. Along the x-axis, we'll increase current input to the coil to its maximum recommendation, and then reverse it. Notice there is no output flow until enough current is present at the coil. At that point, seal liftoff occurs because the valve's return spring is no longer strong enough to overcome the magnetic force of the solenoid. As current increases, the valve continues to open to a peak value at maximum current. Note that ascending flow is to the right of descending flow. This is normal and illustrates more current is required to open the valve than current present when the valve closes. This is known as valve hysteresis and is measured as a percentage of total current. All proportional solenoid valves have hysteresis. Manufacturers strive to minimize it. Now, with the same curve, we're showing flow capacity, but over time, illustrating a valve's output in application. In the following slides, we'll use this technique to share the more common uses of proportional valves in industry. In cycle-to-cycle applications, the proportional valve is treated just like a common on-off solenoid valve, but energized only to a specific current setting and corresponding output flow with each cycle. Here, flow required for 3 seconds in cycle 1 is different than cycles 2 and 3. With incremental output flow, the valve is energized to a specific current and flow, and later, within the same cycle, automatically adjusts to a final flow. For example, in liquid detergent bottle filling, flow is reduced at the end of the fill to control foam buildup. In applications where a flow acceleration to start or deceleration toward the end of the cycle is required, proportional valves are an excellent choice. In dynamic control, the valve remains energized and continuously responds and adjusts to changes downstream with small adjustments for more or less flow. In these closed-loop systems, inputs from sensors turn into precise output changes for flow, up or down. With proper selection of components, these closed-loop systems can maintain extremely precise performance. Manufacturers recommend controlling proportional valves with current rather than voltage. That's because when energized, coils get warm. Their resistance increases, and additional voltage is needed to generate the same amount of coil force. Current remains constant and therefore a better choice for control. Controlling with current, however, is not as popular as pulse width modulation. On most PLCs and in closed-loop applications, PWM works well. Some proportional valve manufacturers offer valve drivers. These devices allow users to conveniently test, evaluate, and use proportional valves on a benchtop or in a project. Drivers are designed to accept communication signals from PCs and, with a power supply, deliver corresponding output power to drive the proportional valve. Proportional valves can be an excellent addition to equipment, offering flexibility, system simplification, cost reduction, and precise flow control. However, specifying and selecting these valves can be tricky. Most manufacturers have knowledgeable staff available who can help. These specialists can remain available, consulting throughout the adoption process. They'll ask the right questions early on and suggest valves to evaluate. They'll make suggestions when your control system could be optimized or needs troubleshooting. Performance modifications are possible in some applications. It is possible to improve performance at a specific pressure to change the valve's orifice for more flow, or to preset to a maximum flow and a liftoff point as well. In this illustration, the manufacturers set the valve differently without changing internal parts. It all starts with an understanding of the customer's application specifics. It isn't unusual for manufacturers to offer several models to cover a full range of flow from a variety of pressure settings. For example, in their ProControl series, Humphrey offers 3 sizes of proportional valves in several pressure settings. Humphrey also offers 2 specialty proportional valve platforms specifically for OEM customers requiring extremely precise performance at difficult low-pressure settings. Their application engineers are experts and work with the customer to tailor the valve precisely to the need. Thank you for your interest in understanding proportional valves. In the right application, they can be an excellent solution. Talk to a proportional valve manufacturer today.